Welcome back, class, to Mr. Marlowe's math class, spring break edition. Today we're going to be doing some review of replacing letters with numbers. My target today is I understand that a letter represents one number in an expression. When that number replaces the letter, the expression can be evaluated to one number. Okay, so let's take a look at the first example here. Example number 1 says evaluate the following expression when x is equal to 3. And we have 4x plus x squared minus 3x. Okay, so now remember, anywhere I see an x, I'm going to replace it with a 3 because x in this case is equal to 3. All right. So all I'm going to do, my first step is going to be to take this expression and everywhere I see an x, I'm going to write a 3. So I'm going to have 4 times 3 plus 3 squared minus 3 times 3. Now, if you guys hopefully remember our PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, I have to, that's my order of operations, and I have to evaluate this expression using my order of operations. So the first thing I'm going to ask myself is, are there parentheses? Yes, there are. Within those parentheses, right, are there more parentheses? Yes. Within those, are there exponents? No. Is there multiplication? Sure is. Remember, parentheses, two numbers separated by just parentheses, like we have right here, that implies multiplication. 4 times 3 is equal to 12. And then I can just write the plus 3 squared minus, over here, I have 3 times 3, which is 9. Okay? Now again, if I'm going through PEMDAS, I'm going to look at parentheses. Do I have any parentheses? I sure do. I have parentheses where? Right here. And what's in my parentheses? Well, that is 12 plus 3. 12 plus 3 is 15 minus 9. Sorry, 15 squared minus 9. Now I have to go through and use PEMDAS again. Do I have any more parentheses? No. Do I have exponents? Yes, I do. I have 15 squared. Now remember, 15 squared is equal to 15 times 15. And 15 times 15 is 225. So I have 225 minus 9, and 225 minus 9 is 216. Okay, remember my first step, everywhere I see an x, I'm going to replace it with 3 because in this question, x is equal to 3. Okay. Careful though, because in example number 2, well, let's read it and take a look. What is the value of 4x minus 2x squared, or raised to the second power, plus 9x minus 9x plus 6 when x equals 2? So notice it's a different problem and x has a different value. That's totally okay. In this problem, though, we have to consistently write a 2 wherever we see an x. So let's go ahead and rewrite our problem. And everywhere we see an x, we're just going to write a 2. Okay. Using my PEMDAS, my order of operations, I look for parentheses first, and I see some parentheses here. Okay, so I'm going to clean up what's inside of those parentheses, and I got 4 times 2, which is 8, minus 2 times 2, which is 4. That's raised to the second power, plus 9 times 2, which is 18, minus 9 times 2, which is 18, plus 6. Now I'm going to go through again. I'm going to look. Do I have parentheses? Yes, I do. Inside of those parentheses, I have the expression 8 minus 4, which is 4 squared. And then I got plus, well, look at this. 18 minus 18, that's 0, plus 6. Okay? 4 to the second power. Well, 4 to the second power is equal to 4 times 4, which is 16. 16 plus 6 is equal to 22. Okay? And we're done. Example number 3. What is the value of 2z minus 2 plus z squared minus 8 when z is equal to 4? So in this case, everywhere I see a z, I'm going to plug in a 4. So let's go ahead and do that. Notice throughout all these examples, I'm using parentheses to signify multiplication. So, first thing I ask myself, do I see parentheses? I sure do, right here. So let's start by cleaning up those parentheses. 2 times 4 is 8, minus 2 plus 4. 4 squared is equal to 4 times 4, which is 16, plus 16 minus 8. I still have parentheses over here, and I still want to clean those up. So 8 minus 2 is 6. 6 plus 4 is 10, plus 16 minus 8. Okay. 10 plus 16 is 26, and 26 minus 8 is equal to 18. And we're all done. So remember, your value for your variable will change according to the question, okay? And then you just take that value and you plug it in wherever you see the variable, and then you evaluate the expression. So today my target was, I understand that a letter represents one number in an expression. When that number replaces the letter, the expression can be evaluated to one number.